Dear colleagues, it's a very great pleasure to give you some insights about food allergy in Sub Saharan Africa. And it's a real privilege to join this first virtual conference and 26th RDTC International CM. It's very nice to see all of you now virtually due to the corona pandemic, but we are still linked together and I'm looking forward to a very mutual exchange with you. So please feel free also to comment and to put your questions at the end of my talk. Food allergy is something fascinating. Here I just give you an example of a cross-reactivity because between a substance that is somehow injected by a tick bite and then leads to cross allergy with cats and also to red meat, so mammal meat. If you eat it, you react allergic. Finally, there's even cross-reactivity to a drug called Erbitux, cetuximab, used for treatment of ovarian cancer. And all this is linked to the so-called, in brief, alpha-gal, which a sensitization that, by the way, we find quite often in South Africa, maybe due to the lots of ticks that are seen there, maybe also to other sources like parasites. In food allergy, we have to discriminate between real allergy, which is Ig-mediated, which causes mostly oral symptoms, but can cause also systemic anaphylaxis, like shock, asthma. On the other hand, we have an increasing area of intolerance with lactose, fructose, histamine, or not celiac, not wheat allergy, the so-called wheat hypersensitivity, excluding celiac and Ig-mediated wheat allergy. On the background, you see a title of a book in German that says, "Silly like bread." So if you eat too much bread, you get silly because it's affecting your brain. So there's a lot of mites and a little bit of facts also in this intolerance area. For you, what you should remember is food allergy can be really life-threatening. It's rare, but it can kill someone. Food intolerance can disturb your life, reduce your quality of life heavily, but usually or almost never it's killing the one who suffers from it. Food allergy is quite common in Europe. Here you see the numbers between 5 to 12%. It's a little bit higher in small children than in adults, but still relevant. Food intolerance is even more common. However, here we are speaking about food allergy in Africa, and there's a very nice article from our colleagues from Botswana and South Africa, which were saying, is it a myth or reality? So they come even to numbers that are higher in Europe, 14 to 18%, rapidly increasing as you see, for sure also due to the fact that there's now registry or recording of food allergy. They mentioned Tanzania. There's a report from 2008 asking in 400 households and 70% reported having food allergy. However, of course, self-reporting is not very reliable, as if someone does not like something, he might confound it with allergy, but still there's a relevant part of it, also in Sub-Saharan Africa. How can you diagnose food allergy? Okay, just take a very good history. I will show you the symptoms are often the key factor. Then, of course, you can do skin tests, sophisticated in vitro laboratory, measuring specific Ig gets more and more frequently accessible also in Sub-Saharan Africa. We have cellular assays, and finally, if all the other tests are not conclusive or if it's very important to prove a food allergy, we can do a so-called provocation or challenge test that we give the culprit or suspected food to a patient and see whether he reacts or not. This is to detect an underlying sensitivity, whether it's still clinically relevant, or to find an alternative if someone is heavily allergic, for example, to some fruits, and we can see by challenge test whether he can tolerate other foods which don't contain the allergenic protein. The main symptoms of food allergy is actually not really gastrointestinal. The main symptom is an oral itch, a burning. If you eat the food that you are allergic to, it starts to scratch, to itch in the mouth, a tingling feeling. This is very typical, and it can remain with that if you eat some food where the allergenic protein is digested by the saliva or by the acidity of the stomach. Or in case this is not digested, then it can cause severe allergy, manifesting with skin symptoms, urticaria, quincke edema, respiratory problems like an asthma attack, sometimes gastrointestinal problems like diarrhea, vomiting, and cardiovascular problems like collapse. So gastrointestinal problems can be part of food allergy, but not the leading symptoms. If you have someone with gastrointestinal symptoms only, I would first look for other underlying disease like bacterial parasitic infestation or other causes of gastrointestinal problems. I'm focusing mostly on atopic dermatitis, as we had this very nice meeting in April 2019. Some of you in the room, like John Masenga and Gail Todd, they were also present. Also the colleagues from Ethiopia, many others, and we put together and could show that atopic dermatitis is really a relevant problem in Sub-Saharan Africa. On the very right, you see Claudia Lang, a consultant at our department in Zurich, which got heavily interested into this disease, especially also in the African background. And as we know that Emma Gutmann, a very well-known researcher and dermatologist from the United States, has already compared Caucasian, so European American AD with Asian AD, and seen very prominent differences. We were starting a collaboration between our colleagues in Moshi, led by Professor John Masenga, Hashim, and George, which joined in Claudia Lang, who was working in New York, and Charlotte Brücken that you see here. She was joining the RTDC meeting last year, and myself, together with Emma Gutmann, we started this tricontinental project comparing patients from Switzerland with Tanzania and doing some of the measurements in the very sophisticated, and I would even call it world-leading lab for AD of Emma Gutmann in New York. We could already summarize some of the findings in the JADV. So last summer, this is published. I put the access to this paper in the chat forum. We compared a small amount, but well-selected AD patients from Switzerland with Tanzania, 10 in each group, and took also 10 healthy controls in Tanzania and Switzerland. So mostly they were quite comparable age-wise. Some of them had additional allergic rhinoconjunctivitis. Others were free of other atopic diseases. We had the privilege by Charlotte Brücken to use a very sophisticated method, the O-link, which gives you an insight about the cytokines for more than 100 cytokines in the serum that you can measure and compare. And we could see that there was really a distinct pattern in the AD patients from Tanzania compared to the AD patients from Switzerland. So a so-called Th17 pro-inflammatory dominated cytokine signature. That means this signature pattern is quite common actually also in Asian patients and also sometimes in psoriasis. So this was very striking, this difference in the AD patients. We couldn't see something like that in the healthy controls, neither in Tanzania or Switzerland. So the immunologic background or what is happening in AD in Sub-Saharan Africa, for whatever reason, genetic, nutrition, infections, might be quite different to the one in Caucasian or Swiss patients. This may sound a little bit academic to you, but I'm sure you are aware that now we are starting to use so-called biologics which address some specific cytokines. And it might be that some of these drugs that work wonderful in Caucasians will not work that well in the Sub-Saharan cohort of patients, or vice versa. Of course, nowadays the access to these drugs is still very limited due to their really exorbitant price, but that might change one day so that even here in Sub-Saharan Africa you have access to these very elegant drugs to treat severe forms of AD, like we have it already for psoriasis or other diseases. However, we were in this group also looking for sensitization patterns for food, plants, microbes, pets. We all agree pet keeping is very different in Europe, where we have our own cat in the living room, the dog is inside, horse riding is popular, while in Tanzania it's more keeping, maybe like chicken or even cows for use. Very few people keep pets indoors like in Europe, but it's interesting to compare. Here, first I show you the results for total IG. This was elevated in AD patients from both groups, but here you see the summary, but not significantly different from AD patients from Tanzania to Switzerland. And for healthy controls, there was again no significant difference. But AD patients had a higher total IG. We are thinking that parasites may play a role for the high IG, but the screening was negative in both populations, in the Swiss and the Tanzanian population, which is quite surprising, as there are, for example, reports from South Africa where elevated total IG is also found in healthy controls due to strong parasite infestation with Toxocara, which is mainly a parasite infesting dogs. So this we couldn't see here in these Tanzanian groups and Swiss groups. Then we were using a very sophisticated IG measuring approach, the so-called microtiter approach, where you can measure more than 200 allergens from as little as 60 microliter of blood, serum, and it contains many plant allergens, animals like dander, mites, cockroaches, molds, and yeast, and of course also a large battery of food allergens. And that's where I'm coming now. We could find a lot of house dust mite sensitization in the AD groups, both from Switzerland and Tanzania. This is a very common sensitization in both groups. When we are looking at sensitization of cockroach, it looks quite different. Here we found almost exclusively in AD patients from Tanzania, not in Switzerland and not in healthy controls. And then we were quite surprised that we found a lot of sensitization to seafood, also in the AD cohort from Tanzania. These are all seafood allergens. Some very relevant one is tropomyosin that you see here on the very right. This was not found in the Swiss cohort. Now we were really a little bit puzzled because we know that seafood is not a common staple food in Moshi, where these patients come from. The sea is quite far away, and food like you see it here is really not a popular meal in this area. So where does this sensitization might come from? We are really struggling. However, then Andrea Binker, the colleague of us who stayed 3 months last year at the RDTC, found out that on the market, dried shrimps are sold as chicken food. And this seems to be very popular. And we could really detect the allergens that you have in these dried shrimps in chicken food. And chicken, of course, is a common food resource also in the Moshi area. So it might be that the food that your chicken eats, may lead to a sensitization on a later stage. This is still ongoing. we are focusing on very specific methods like mass spectroscopy, but it's a very interesting observation that, of course, we follow up, as it might have a big impact on the also food procedure, what you feed to your food sources. So if we compare, there's food allergy in some reports from South Africa. 80 is common. 80 patients have commonly sensitization, and our colleagues from there, they report on oranges or other foods, seafood. This is quite similar to the orange. I return. And if you want to look at, there's a very recent study, molecular IG sensitization profiles in urban and rural children in South Africa from a group from South Africa and Austria. They also found, like in the Tanzanian cohort, that house dust mite sensitization is very common. Hensack is the most common food-related sensitization. We didn't find that so much in our cohort. And also sensitization to peanut was quite common in a rural area, more common than even in the cities, although there's less peanut exposure there. So this might be another thing, that exposure to a reduced amount, like before, to tropomyosin may lead to higher sensitization rate instead of inducing tolerance. We are making progress in Switzerland as we adapt our food habits also, and free insects are now declared as eatable and allowed insects, the mealworm, cricket and migratory grasshoppers, and they are prepared to insect burgers, which you can buy now in the shops and which has become very popular among our young people. We have already seen some patients reacting allergic to these insects because there's a strong cross-reactivity with seafood. So now we are having initiated by the promoting of Carol Gier, a resident at our department, a study called InFood, where we compare sensitization patterns to house dust mites, seafood, and these insects. We have developed skin prick tests, basophil activation tests. We'll measure specific IgE. Here you see the original insects. See a little bit how this was working on. So now this study has just started, and I'm very much looking forward to report more on this in next year, and hopefully we can also detect from this some allergen extracts which are useful in an African context, where, as you know, in some countries, like for example in Uganda, the eating of grasshoppers is very popular. It's even a delicacy. So if you think I would never eat insects, you could be wrong, because insects are widely used. So for example, there are in the orange wax, which is made from shellac, oranges are treated that they don't lose their liquid, that they look pretty. The carmine red, which stained Campari so nicely, was also made from lysis in early years. Nowadays it's changed to artificial food colorants. And if you use powdered rings containing carnitine, this is again made from insects, this protein. So if you have your next drink, you might also have not only a drink, but also some insect parts in it. Finally, a few words on the therapy of allergic diseases, especially food allergy, where usually treatment of allergy is based on 3 pillars: allergen avoidance, drugs that can control the symptoms, and allergen-specific immunotherapy. Especially allergen avoidance has been really challenged by this study by George Dutoit and colleagues that has been published now. It's already almost 6 years ago in the New England Journal. They made 2 groups of small children. One group received on a regular daily basis peanuts up to the age of 5 years, while the other group had to avoid peanuts the whole time. Unsurprisingly, the rate of peanut allergy was much lower in those groups that had continuous peanut ingestion. So the ones that always had peanuts were less at risk to develop later peanut allergy. So avoidance may be not the real answer, much more maybe a regular consumption of a food to avoid food allergy. We have now also very nice drugs, sophisticated, expensive, but very efficient, like omalizumab, anti-IgE, which can control very severe food allergy. This is a report from the colleagues in Italy, where they reported more than 23 patients who were treated with omalizumab and then later on supported much more of the food allergy that they couldn't eat before. We have also immunotherapy, oral and epicutaneous, so via patch, addressing peanut allergy, quite successful, and there are publications like the one with the oral immunotherapy who was published 2.5 years ago, and the other one with the patch test unit, and show very nice results that if you treat children with regular intake of peanuts, you can induce that they tolerate much higher amounts of allergen, of peanut allergen, as you see here. This is the allergen treated group, while the ones here receives placebo. And this works really very convincingly, but we have to say it works only in children. After the age of 15, there's not much effect of this immunotherapy, and it's also quite dangerous in adults because you can have severe allergic reactions. Here is just a small example how patch immunotherapy, epicutaneous immunotherapy works. You have a small patch test where you put some proteins of peanuts, you leave them on the slightly reduced skin so that it's more penetrable for a few days, and like this, with this continuous application of peanut allergens, you can also induce tolerance. Quite elegant, especially for children. They of course prefer this, such a patch on the back. They don't feel a lot, than to oral immunotherapy, or even worse, to subcutaneous immunotherapy, where they would get injections. Finally, I would like to lose one word on the vaccination. There's also vaccination strategies against food allergies. For example, these methods where they use virus-like particles. They imitate a virus so they can penetrate into the body and are presented to the immune system. And because they are loaded with peanut allergens, that's a way to induce tolerance. By the way, the same method is used nowadays for the COVID-19 vaccination. Some vaccines, like the one from Astra, are based on a very simple principle. If this principle of these virus-like particles loaded with food allergens, that works already very nice in mice, will work also in humans. This may really be a big step, a big progress for the treatment of food allergy, which still can be very much hampering, disturbing the life, and still be dangerous and life-threatening. So with this, I come to my thanks to a very nice Asante Sana Kwarafiki Wote, to John Masenga, George Semango, Hashim Kaderbay, and Daudi Mavura, which really did a wonderful job collecting the patients very properly, documenting them so seriously, and having samples that were of the highest quality. Now we have other young collaborators like Glory Masenga, and so it's really a pleasure that to co-work, which was also realized by our partner in New York, Emma Gutmanyaski. She was very much impressed by the quality of the samples that we had in the Tanzanian cohort. Last but not least, I would of course like to thank to my co-workers Claudia Lang, Charlotte Brücken, which have initiated the study, which by their lab experience from Charlotte made only possible all these experiments then the people from the lab, Andrea Binkert, who has worked and contributed to the study, people who work on other areas like the mycological aspect, the mass spectroscopy. Altogether, I hope we can contribute something to a better understanding, maybe better treatment and management also of AD in Sub-Saharan Africa and for food allergy in this area. And with this, I thank you very much for your attention. I hope you can have now a short break, and I wish you a good continuation for this meeting that already now I would like to congratulate to Daudi Mavura and the RTTC team, Pedro and all the others, that made it possible to have such a wonderful virtual meeting with a very exciting program and technically on the very high standard, functioning so well. I'm deeply impressed. Thanks a lot.